Alright, welcome to another video. Last video I had a technical difficulty. My setup here, I think my computer powered off or something randomly, so but I did save my where I left off, so I'll just start from there for this video. And this video is going to be a part of the Cosmic Python series, kind of having my doubts as to whether this is the book for me, but I don't want to just keep switching books. So last time I ended here, so I'm going to move this down to the previous bookmark. Alright, and then I will blank this out. Alright, and then let's waste no time. Number one, here's the first function we factor out, read paths and hashes, which isolates the I/O part of our application. Here is where we carve out the functional core, the business logic. So we can see we've got they're factoring this out and they're making a function, so we should see that down here. Yep. And then here we carve out the functional core, the business logic. The code to build up the dictionary of paths and hashes is now trivially easy to write. Trivially, right?
Trivial.
Well, trivially. I think that's it, trivially. The determine actions function will be the core of our business logic, which says, given these two sets of hashes and file names, what should we copy, move, delete? It takes simple data structures and returns simple data structures. All right. So we've got a yield statement here. It's interesting. Our tests now act directly on the determine actions function. All right. Because we've disentangled the logic of our program, the code for identifying changes, from the low-level details of I/O, we can easily test the core of our code. With this approach, we've switched from testing our main entry point function, sync, to testing a lower level function, determine actions. You might decide that's fine because sync is now so simple, or you might decide to keep some integration/acceptance tests to test that sync. But there's another option, which is to modify the sync function so it can be unit tested and end-to-end tested. It's an approach Bob calls edge-to-edge testing. All right, testing edge-to-edge with fakes and dependency injection. When we start writing a new system, we often focus on the core logic first, driving it with direct unit tests. At some point, though, we want to test bigger chunks of the system together. We could return to our end-to-end tests, but those are still as tricky to write and maintain as before. Instead, we often write tests that invoke a whole system together, but fake the I/O, sort of edge-to-edge. Explicit dependencies, sync.py. So this is not a test. I'm not sure what this is all about. We'll actually find out. Our top-level function now exposes two new dependencies, a reader and a file system. Right here. Number two, we invoke the reader to produce our files dict. Number 3, we invoke the file system to apply the changes we detect. Tip: although we're using dependency injection, there is no need to define an abstract base class or any kind of explicit interface. In this book, we often show ABCs because we hope they help you understand what the abstraction is, but they're not necessary. Python's dynamic nature means we can always rely on duck typing. What the heck is duck typing? I am so confused. Duck typing. Duck typing is a concept related to dynamic typing, where the type or the class of an object is less important than the methods it defines. When you use duck typing, you do not check types at all. Instead, you check for the presence of a given method or attribute. You see, and this is coming from real Python. Like, honestly, I think I'm going to be better off just doing real Python tutorials instead of reading books. Yeah, like this would be awesome. I want to build a platform game. Like I want to just learn how to like build games using Python, because I think like if I want to get better at Python, like that's going to help me get really good at it. And it'll just be like a unique skill set in some way. Anyway, let's keep going. So, okay, here we've got the class. So, yep, we've got descriptions here. Bob loves using lists to build simple test doubles, even though his coworkers get mad. It means we can write tests like assert foo not in database. Each method in our fake file system just appends something to the list so we can inspect it later. This is an example of a spy object. So this is a spy object, which is strange. I mean, I thought that was a method. I don't know. I guess if you instantiate. Yeah, I'm not sure why they're calling this an object. Like, because I would think you would like. Yeah, I'm completely lost. But let's just try to keep going. The goal is not to understand every single little thing. It's just to get exposure and to kind of be able to take my notes with me. And if eventually down the line it does click or it rings a bell or it seems useful, I'll be able to call back on it. The point is recall, not real-time understanding of a word. Is being able to recall it when it matters in the future, if it does. Which is premature optimization in some way. That's why I've been switching books, because ideally I would have as much information that is immediately relevant as possible, but that's kind of a bit too much to ask from resource to resource. So the advantage of this approach is that our tests act on the same function that's used by our production code. The disadvantage is that we have to make our stateful components explicit and pass them around. David Heinemeier Hansson, the creator of Ruby on Rails, famously described this as test-induced design damage. In either case, we can now work on fixing all the bugs in our implementation. Enumerating tests for all the edge cases is now much easier. Why not just patch it out? At this point, you may be scratching your head and thinking, why don't you just use mock.patch and save yourself the effort? We avoid using mocks in this book and in our production code too. We're not going to enter into a holy war, but our instinct is that mocking frameworks, particularly monkey patching, are a code smell. Code smells are something that's interesting as well. In computer programming, a code smell is any characteristic in the source code of a program that possibly indicates a deeper problem. Determining what is and what is not a code smell is subjective and varies by language developer and development methodology. There's also a term used by agile programmers. So they're not talking about a good smell when they're talking about code. They're not talking about the smell of roses or essential oils. Cold smells are symptoms of poor design or implementation choices. And is this, I guess this is a picture of Martin Fowler. I'm kind of surprised he looks like that, but looks like he's a magician as well. Instead, we like to clearly identify the responsibilities in our code base and to separate those responsibilities into small, focused projects that are easy to replicate with a test double. I'll show you, let's see here, university. I just want to kind of show what I thought Martin Fuller would look like. Yeah, like I thought he'd look like this, or like maybe even like this, possibly like that, but yeah, I was expecting him to be older, I guess. Note, you can see an example in Chapter 8, Events and Message Bus, where we mock.patch out an email sending module, but eventually we replace that with an explicit bit of dependency injection in Chapter 13, Dependency Injection. We have three closely related reasons for our performance. Patching out the dependency you're using makes it possible to unit test the code, but it does nothing to improve the design. Using mock.patch won't let your code work with a --dry-run flag, nor will it help you run against an FTP server. For that, you'll need to introduce abstractions. Tests that use mocks tend to be more complicated to the implementation details of the code base. That's because mock tests verify the interactions between things. Did we call shutil.copy with the right arguments? This coupling between code and tests tends to make tests more brittle in our experience. Overuse of mocks leads to complicated test suites that fail to explain the code. Note, designing for testability really means designing for extensibility. We trade off a little more complexity for a cleaner design that admits novel use cases. Mocks versus fakes, classic style versus London School TDD, which is test-driven design. Here's a short and somewhat simplistic definition of the difference between mocks and fakes. Mocks are used to verify how something gets used. They have methods like assert called once with. They're associated with London School test-driven design. Fakes are working implementations of the thing they're replacing, but they're designed for use only in tests. They wouldn't work in real life. Our in-memory repository is a good example, but you can use them to make assertions about the end state of a system rather than the behaviors along the way, so they're associated with classic style test-driven design. We're slightly conflating mocks with spies and fakes with stubs here, and you can read the long correct answer in Martin Fuller's classic essay on the subject called Mocks Aren't Stubs. I'm going to add this to my further reading, but oh, okay, yeah, okay. I knew what Martin Fuller looked like, so I guess I shouldn't have been surprised because he looks like the picture he has up on his blog. I'm going to add this here. So this book really likes Martin Fuller. I don't know if it was written by Martin Fuller or if the authors know this person, but this is like the LeBron James or Michael Jordan of code design. Which for me would be Kenneth reads or writes. Yeah. So I don't know. Huh. I guess that could be one that I read, The Hitchhiker's Guide to Python. Yeah, this looks like... Yeah, I don't know. We'll just keep going. It also probably doesn't help that the magic mock objects provided by unittest.mock aren't strictly speaking mocks. They're spies, if anything, but they're also often used as stubs or dummies. There, we promise we're done with the test double terminology nitpicks now. What about London School versus classic style TDD, test-driven design? You can read more about these two in Martin Fuller's article that we just cited, as well as on the Software Engineering Stack Exchange site. But in this book, we're pretty firmly in the classicist camp. We like to build our tests around state, both in setup and in assertions, and we like to work at the highest level of abstraction possible rather than doing checks on the behavior of intermediary collaborators. More on this in kinds of tests. Guess I would go with Chicago style because I'm from the Midwest. But I would definitely, yeah, I don't know. That's probably a really bad way to pick between the two, just based on what they're called. We view test-driven design as a design practice first and a testing practice second. The tests act as a record of our design choices and serve to explain the system to us when we return to the code after a long absence. Tests that use too many mocks get overwhelmed with setup code that hides the story we care about. Steve Freeman has a great example of over-mocked tests in his talk, Test-Driven Development. You should also check out this PyCon talk, Mocking and Patching Pitfalls, by our esteemed tech reviewer, Ed Zhang, which also addresses mocking and its alternatives. And while we're recommending talks, don't miss Brandon Rhodes talking about hoisting your I/O, which very nicely covers the issues we're talking about using another simple example. Tip: in this chapter, we've spent a lot of time replacing end-to-end tests with unit tests. That doesn't mean we think you should never use E2E tests, end-to-end tests. In this book, we're showing techniques to get you to a decent test pyramid with as many unit tests as possible, and with the minimum number of E2E tests you need to feel confident. So the goal isn't just never to use end-to-end tests anymore, it's to abstract, create that layer of abstraction. So for most things you can use a unit test, but just those things that just don't fit under your layer of abstraction, which will be not that many if you define your abstraction correctly. Then you can use end-to-end tests. Read on to types of test rules of thumb for more details. Okay, I think I'm gonna save these talks. I don't know. Like, honestly, I just don't think these are, because they're gonna be really dull. These talks are gonna be really dull. Like, I don't know, and like, I don't know if it's going to be relevant to me. Like, it's just hard to know.
I don't realize it.
But I'll save them. I'll save them. So yeah, we'll name this one this. For the rating, okay, we'll say we'll make a talks. So which do we use in this book? Functional or object-oriented composition? Both. Our domain model is entirely free of dependencies and side effects, so that's our functional core. The service layer that we build around it in Chapter 4 service layer allows us to drive the system edge to edge, and we use dependency injection to provide those services with stateful components so we can still unit test them. See Chapter 13, Dependency Injection, for more exploration of making our dependency injection more explicit and centralized. Wrap up. We'll see this idea come up again and again in the book, and we can make our systems easier to test and maintain by simplifying the interface between our business logic and messy I/O. Finding the right abstractions is tricky, but here are a few heuristics and questions to ask yourself. Can I choose a familiar Python data structure to represent the state of the messy system, and then try to imagine a single function that can return that state? Where can I draw a line between my systems, and where can I carve out a seam to stick that abstraction in? What is a sensible way of dividing things into components with different responsibilities? What implicit concepts can I make explicit? What are the dependencies, and what is the core business logic? Practice makes less imperfect. And now back to our regular programming. Okay, so we've got a use case here, Flask. I'm tempted to stop it here because oh. Okay. Yeah, it looks like some of the commenters are following along with this in the code. I've kind of not been doing that, but let's try to see if I can get one more in here. Back to our, okay, so our first use case, Flask API and service layer. Back to our allocations project. Before we drive our app by talking to repositories and the domain model, shows the point we reached at the end of Chapter 2 repository, which covered the repository pattern. All right. In this chapter, we discussed the differences between orchestration logic, business logic, and interfacing code, and we introduce the service layer pattern to take care of orchestrating our workflows and defining the use cases of our system. We also discussed testing by combining the service layer with our repository abstraction over the database. we're able to write fast tests, not just of our domain model, but of the entire workflow for a use case. The service layer will become the main way into our app, which is the name of this graphic down here. Shows what we're aiming for, and we're going to add a Flask API that will talk to the service layer, which will serve as the entry point to our domain model. Because our service layer depends on the abstract repository, we can unit test it by using fake repository, but run our production code using SQL Alchemy repository. All right, and I'll have to take their word for it. Let's just move on. In our diagrams, we are using the convention that new components are highlighted with bold text / lines and yellow / orange color if you're reading a digital version. The code for this chapter is in chapter 4, service layer branch on GitHub. Okay, you know what? Let's pull that code down and try to follow along. I've got my GNS lab started up, hopefully. Sometimes if I just leave it up for a while, it shuts itself down for some reason. But yeah, that's actually what happened. So let's just refresh everything. Yeah, reload all the devices. Okay, and then I should be able to get in. Alright, so I think what happens is the project closes after a while. Yeah, see how it says close? So I've got to reopen the project. I'm not sure why that happens. It's really annoying. I wish the project would just stay open indefinitely until I close it. All right, next section, connecting our application to the real world. Like any good agile team, we're hustling to try to get an MVP out and in front of the users to start gathering feedback. We have the core of our domain model and the domain service. We need to allocate orders, and we have the repository interface for permanent storage. Let's plug all the moving parts together as quickly as we can and then refactor toward a cleaner architecture. Here's our plan. Number 1, use Flask to put an API endpoint in front of our allocate domain service. Wire up the database session and our repository. Test it with an end-to-end test and some quick and dirty SQL to prepare test data. Refactor out a service layer that can serve as an abstraction to capture the use case, and that will sit between Flask and our domain model. Build some service layer tests and show how they can use fake repository. Number 3, experiment with different types of parameters for our service layer functions. Show that using primitive data types allows the service layer's clients, our tests and our Flask API, to be decoupled from the model layer. A first end-to-end test. No one is interested in getting into a long terminology debate about what counts as an end-to-end E2E test versus a functional test versus an acceptance test versus an integration test versus a unit test. Different projects need different combinations of tests, and we've seen perfectly successful projects just split things into fast tests and slow tests. For now, we want to write 1 or maybe 2 tests that are going to exercise a real API endpoint using HTTP and talk to a real database. Let's call them end-to-end tests because that's one of the most self-explanatory aims. The following shows a first cut. Okay, so after I pull this repo down, we should see that file without having to type it out. I want to now start to follow along and get this code to work. I just think I'll get more out of that. And then, of course, I do want to work on this project here. Let me see here. Network chart. Plotly. Visualizing networks in Python. Practical guide to tools that help you see the network. Network X. Oh. Yeah, but I want PyVis. Is that like Visio? No, it stands for visualization. I guess that, yeah, this would be pretty cool. This looks okay. I kind of like PyVis. Especially if you can like yeah, I like PyVis the best, I think. I don't like this one, there's not enough. What's Network X? Okay, Network X. Complex networks. Okay, yeah, this one looks interesting. This looks interesting too. Network graphs. Plotly. Yeah, as long as you can like provide, yeah, like this looks pretty easy to work with. Let's try this. So we're gonna go. I'm getting a little. I might seem like I'm getting off task, but the goal is to work on this project here. So one thing I do have is LLDP set up on all my devices. So if I open one of my Arubas I've got here. Oops, and there's a car outside being noisy. There we go. I've got my LLDP neighbors, so I can pull back that information if I set up a management network. So let's do that now, and I'm kind of getting away from this book here, but part of what I wanted to do. So let's just read this code. We'll get down here. Save that as a current bookmark and then go off the rails so I don't lose my spot. So number one right here, random SKU, which is a stock keeping unit, random batch ref, and so on are little helper functions that generate randomized characters by using the UUID module. Because we're running against an actual database now, this is one way to prevent various tests and runs from interfering with each other. Line 2 down here. Add stock is a helper fixture that just hides away the details of manually inserting rows into the database using SQL. We'll show a nicer way of doing this later in the chapter. Okay, number 3 right here. Config.py is a module in which we keep configuration information. Everyone solves these problems in different ways, but you're going to need some way of spinning up Flask, possibly in a container, and of talking to a post-GRES database. If you want to see how we did it, check out appendix project structure. Okay, so now I will move my bookmark, my current bookmark here. Okay, and I might end up reading more of this by the end of this video, but I want to kind of go off the rails a bit and think about my code along project that I plan to do along with this video. So I think I'll be using Plotly. Now what is dash? Dash is the best way to build an enclosed claw using Plotly figures. Okay. What is dash? And how is it different than Plotly? What's a cytoscape? Okay, well anyway, let's start by making a management network. So we're already going off the rails a little bit, because what I wanted to be able to do is just take another open vSwitch, plop it down, and then automatically get integrated into the network with basically no configuration on it, except for like DHCP on an interface and like allowing the management VLAN through. Yeah, so unfortunately, the way things are now, it's not really set up like that. But let's get, okay, so we've got our public IP here. Let's create a management network. So yeah, so for our, yep, so we're going to do it like this. We're going to have a management VLAN, which I think will be the highest available VLAN, which is either 4095 or 409. I think it's 4095, so we'll configure VLAN 4095 on all of these devices. And can I do 496? No, but I can do 4095. Yep. Cool. It looks like 4094 is the highest one I can do. Okay, and then interface VLAN 4094 IP address, and we'll put a DHCP address on that. Oh! How do I configure a DHCP address? IP Can I not configure this to have a DHCP address? I don't get it. I thought that would be possible. Forward protocol? What does that mean? UDP? Okay, it looks like I can't do a DHCP address. That's really strange. I thought maybe like there was something special about the 4094 VLAN where other VLANs would have the ability to do DHCP, but that does not appear to be the case, and I would be surprised if that were the case, but I'm pretty new to Aruba, so it could be. Alright, so shoot. IRDP, IGMP, help our address? I'm really confused here. So I can't do a, what if I do, oh, okay, so here I think I can, let's try this. Okay, so it failed because we've got a custom startup configuration. Oh, it's been replaced by NetPlan. Um, Okay, so for the management network, it's going to be 10 dot for 409694, because that's the management VLAN, and then we'll give this dot one. We'll give a net mask of /24. There you go. And we don't need a gateway. We'll just do one large. Yeah. Okay. Okay, and then we'll actually give a okay, then we'll need to make this a switch port. Yeah, I've got to configure the port connecting to it, which is 9. Oh, here we go. Okay, it is 9, isn't it? Yep. why I can't ping across the wire. Oh, I didn't lose anything at all. I should have like general failure. Or something. I mean the port is up. Huh. Yep, it says that it's up, but I just can't ping. And, 42. Huh. I do not understand. So it's not able to ARP. Okay. It's just so weird that the link is up. I don't get what I'm missing here. I mean, there's no VLAN on this side. Do I have the right? Are they in the same subnet? Oh, maybe this needs to be no shut. But I mean, I'm able to ping it. No. Yeah, I'm really confused here. I don't get why this isn't working. You know what I can do? That's myself, but pinging across the wire fails. I can do a capture to try to figure it out. Okay, it's ARPing. It's sending lots of ARPs. It's got LLDP for it. On, oh, it actually doesn't have LLDP on 119. Oh, I get it. So it looks like on these Arubas, 119 is a special management port, so it doesn't even have oh, but it looks like it's showing up on 118 because we can see the port ID, port description, port ID. These are connecting to Junipers. So I think it's just shifted up. So 8 means port 9, 7 means 6, and then 0. So 1. So here, let me make this clear. So yeah, I think it's shifted. So 111 is actually the MGMT port, and 112 is actually 111. And we can see that makes sense because 111 here and 112 here are connected to 2 Junipers, but 111 here does connect to the Juniper, but 1112 does not connect to a Juniper. This MGMT port does. So here, so yeah, that's the problem, is I'm configuring the wrong port. I gotta configure 118 instead of 119. And I'll need to figure out what I wanna do with this MGMT port, because that's not gonna work. Oh, I think that's myself. Let's see if I can ping the other FPU as well. Okay, yeah, that was the problem. I was configuring the wrong port. Okay, so let's try to get access everywhere, which is not going to be easy at all. Okay, but now I can do a SSH. Oh, actually, I'll need to set up SSH. Yeah, connection refused. But I can probably do that. You know what I might do? I might just use key authentication. But that's kind of hard. Yeah, so public key authentication. Alright, so I think I'm going to need to do more than that, but let's see. Oh, actually, no, I've got him there. So, yeah, I need to, like, have my public key be in there. Host keys. Okay, so here's the key. So I think I can do cd.ssh, and now, yeah, we've got our known hosts here, but I think I can do authorized. Oh, you know what? I think that makes it so that they can SSH to me without a password, but I want to make it so that I can SSH to them without a password. Yeah, because if I can add it to the authorized key file, but that would make it so that, but that's not what I want to make it so I can SSH to them without a password, so I'd have to put it in their version of an authorized key file. Alright, so that's not going to work. Okay, I think it will work to put it on the other side though. Oh. No. Um. Hmm. All right. I am really confused here. I thought you could like add a key because I know in Junipers you can like add a key. So I thought you could do that here as well. Public key authentication method enabled by default. So how do I what does auto confirm do? Uh, all right, that works. but I wanted it to just allow it. Oh, they want you to go to a like a GUI. I mean, I can do that. Let me do that. Yeah, I don't know what's going on. So this video is yeah, it's past an hour, so this might need to be it. Let me see if I can. Yeah, so we're gonna enable the HTTPS server, VRF, GNT. Maybe that'll do it. Or maybe it's got to be for the default. Oh, here we go. Yeah, okay. It's got to be for the. Oh. Oh, I clicked the go back instead, so we got to click on advanced, and then accept the risk and continue. All right, this is what I'm looking for. This is the device, but it's just instead of in through the SSH, we're going in through HTTPS. And we're going to configure it that way. So we're going to go to, on the left here, system. Some devices are like meant to be, like the manufacturer, like really, because a lot of devices, a lot of new vendors are kind of getting away from the CLI a bit. And focusing more on like GUIs and then like API automation. So like going in and like kind of like command line jockey type stuff. A lot of vendors are trying to get away from. So if we go to configuration management general, we should see SSH. I don't see. Oh, here we go. Configuration management. And then general. I don't see general anywhere. Here we go. Configuration. And then management. Is there anything for... So I see it for... I'm surprised LLVP status is off because I did enable that. That's for connected devices. I'm not sure what that means. This is checkpoint. Yeah, I don't know. I don't think, I just don't think they're allowing for that. I don't think you can do it. What's PKI? I'm not sure what that is. Oh, it looks like there's a lot more stuff here. There's a certificate. Yeah, I don't see anything for SSH. Looks like they're almost not really expecting that. Oh, here I can create a certificate. Not sure what this EST is. Alright, well, I think I'm going to end it here. Yep, so the next video is going to be starting here, the straightforward implementation. Thanks for watching. See you in the next one.